Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 15 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 342, power of 4. Let's read the problem statement. Given an integer n, we have to return true if it is a power of 4. Otherwise we have to return false. An integer n is a power of 4 if there exists an integer x such that n is equal to 4 power x. Okay, now here if you see example number 1, n is equal to 16, right? So can I write my n, which is 16, is equal to here 4, and in place of x, if I write 2, what I'm going to get? 4 power 2 is nothing but 16, right? So yes, I can write it. So output is true, right? Now here n is equal to 15, but here I can't write it in any power of 4, right? This 15, so output is false. Same way n is equal to 1, so I can write it like this, 4 power 0, which is 1, right? So output is true, and these are the constraints. And follow-up is, could you solve it without loops and recursion? Okay, so I'm going to solve this problem using 4 approaches, right? So let's first use this problem using loops, then recursions, then I will show you the optimal approach, okay, in which we are not going to use any loops and recursion. Okay, so first with the loops, how you are going to solve it? So it's very simple. First of all, even if you take smallest value of x here, which is 0, okay, so you are going to get 1, right? So if your n value is less than equal to 0, then you have to simply return false. So here I'm going to write if n is less than equal to 0, then simply return false from here. Okay, return false, done. And here I'm simply going to run one while loop, and here let's suppose your number is 16, right? So if I do 16 modulus with 4, what I'm going to get? I'm going to get remainder as 0, right? Okay, if I'm getting the remainder as 0, so that simply means that 60 is completely divisible by 4. Okay, so next time what I'm going to get, if I divide 60 with 4, I'm going to get 4 only, right? Done. This is done. Now after that, after this 4, take this 4 modulus with 4. Okay, so here also it is completely divisible by 4, right? So next time what I'm going to get, I'm going to get 1. Okay, done, right? Now next time if I do 1 modulus with 4, I am going to get my remainder as 1 here, right? So let's stop it here. Okay, I'm only going to proceed when my remainder is 0, right? So now I'm stopping here. Now in the end, okay, after this, in the end, I'm just simply going to check if the last value of n which I checked, if it is equal to 1, then simply return true, otherwise return false. That's it. So here n modulus with 4, okay, and here equal to 0, then in that case n is equal to n divided by 4, done. And here we have to simply return n is equal to 1, then true, otherwise false. Now let's run it. So see, all the test cases has been accepted, right? Now let's submit it. So see, our solution is accepted, right? And the time complexity for this one is log base 4 and n here. All right, so if you see this, n is equal to 4x. Okay, n is equal to 4 power x. I can write it like this: x is equal to log base 4 and n here. Okay, so this is my logarithmic time complexity, right? 16, then I'm taking 4, then 1, that's it. Okay, clear? So this is using loops. Now same way you can solve this problem using recursion, right? So here for recursion, what you need to do, so here for recursion, base condition is that if your n becomes equal to 1, then in that case you have to simply return true. Okay, and if your n is less than equal to 0, or I can say if n modulus with 4, the remainder, but the remainder that I'm going to get if it's not equal to 0, right? So in that case also we need to return false, and otherwise I'm just going to call this is power of 4, this method, and inside this I'm just going to pass n divided by 4. That's it. So this is my recursion code. Now let's run it. So yeah, return is missing, so here I'm just going to return is power of 4 and divided by 4. Okay, now let's run it. So see, all the test cases has been accepted, right? Now let's submit it. So see, our solution, recursion solution is also accepted, right? Okay, done. So for this one also, the time complexity is log base for n. Okay, done. Now next time, my approach 3, in which I'm going to solve this problem using this log only, right? So what I'm going to do, I'm doing here, so I'm just calculating this now, log 4 and log 4, and here I'm passing 16. Okay, I can write it like this, log 16. Okay, and here I can write it like this, log 4, right? This is how we solve this, right? So this log 16, and here I'm writing log 4. All right, so now here, what is this log 16? Log 16 is nothing but, I can say log uh, 2, and here 2 power 4, right? And this is nothing but log 2 square, right? 4, and this is 60, right? 2 into 2 into 2 into 2. Okay, now here I can say this 4 log 2 and 2 here, and here I can say 2 log 2 and 2 here. Done. Clear? Now I can cancel out this one. So what I'm going to get here, 4 divided by 2, which is nothing but 2, right? And here I will say 2 modulus with 1, right? The remainder is going to be 0, right? In this case, if I take this, right? Same way here, if you solve log 4, and here let's say you pass 15, right? So how you are going to write, you are going to write log 2, and here 15, and here log 4, right? Here 2. So here let's say you are going to get log 2 and some value of 15, let's say 15 here only, right? Here you are going to write like this, log 2 2 and 2 here, right? So here how you are going to solve it, how you are going to solve it, you are not going to cancel out like this log 2 2, right? You are not going to cancel out this, right? So in this case you have to simply return false. Okay, so that's what I'm going to use. So if I'm going to get output like this, okay, here cancel out everything, and here I'm getting some result, right? And if I'm doing the modulus with 1 and I'm going to get 0, then I'm going to simply return true in that case. Okay, so here what you need to do, move everything, and here you have to just write return. First of all, we have to make sure that n value, it should be greater than 0, and here you have to write math 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 dot log, and here n, okay, here divided with math dot log, and here divided by 4. Okay, math dot log pass 4. Okay, and whatever the value that I'm going to get here, right? All right, so whatever the value that I'm going to get here, I have to do the modulus with 1. Okay, if the value comes out 0 here, I can say, then in that case simply return true. Okay, so if this is a condition or this, both are pass, right? So return true. So now let's submit it. So see, this solution is also accepted, right? Okay, so this is the third way to solve this. Simple. Okay, based on time complexity, right? This is the time complexity that we are getting every time. So I just use that. Okay, log 4 base 4 and n. So I can write it like this. So further, if I want to solve, I can solve it like this. So here everything cancel out, here I'm getting 0, but here in log 4 15 I will not get this. Okay, the same result, because this is not in the power of 2, right? Okay, so in that case we are not going to get our desired output. Okay, so we have to return false. So this is done. This is the third approach. And fourth approach is, right, so fourth approach is like n is equal to 1 you have, then let's say 2, let's say 4 you have, let's say you have 16 8 16, something like this. So here if I write it binary form, I can write it like this 0 0 0 1, right? If I want to write 2, I can write it like this 0 0 1 0. If I want to write 4, I can write it like this 0 1 0 0. Okay, this 8 I can write it like this 0 1 0 0 0. Okay, and 16, how I'm going to write, I'm going to write 16 like this. Okay, done. This is how I'm going to write. Okay, so this bit value is 1. Okay, let's say 2 power 0 1. This is 2 power 1, that is 2. This is 2 power 2, that is 4. This is 2 power 3, that is 8. This is 2 power 4, that is 16. Okay, so this is clear, right? This is how we write. Okay, so now here what I need, I need powers of 4, right? So 4 power 0 is nothing but 1. 4 power 1 is nothing but 4. 4 power 2 is nothing but 16, right? And 4 power 3 is nothing but 4 into 4 16. 16 into 4 is nothing but 64, right? Right, 16 into 4 6 4 24. Okay, and 4 1 the 4 5 6, right? 64, right? Okay, so here this, okay, this number we can get right? Then this number we can get, then this number we can get. Okay, 0 1 0 1. Okay, int size is 32 bits, right? So here let's say I am writing 32, 0 1 0 1 0 1 0 1. Okay, here 0 1 0 1 0 1 0 1. Okay, so here 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20. Okay, then here 24, then here 28, and here 32. Okay, int size. So here this is done, right? So I can say that only this bit is set, right? 0, then this 2 3, then this fourth bit. Okay, 0 1 2 3 4. Okay, 5 6 6 7 8. Okay, then 9, then this 10 11 12 13 14 15 16 17 18 19 20 21 22 23 24 25 26 27 28 29 30. Okay, and then 31, right? Starting from 0, right? So here if you notice, if only this bit is set, right? So if only this among all these 32 bits, okay, if only this is set, then in that case I will get 4 part 0, which is 1, right? If this is set, then I will get 4, right? For this one, if this is only set, then I will get 1. Okay, and is equal to 1. Here if only this is set, right? Only if this is set, so here this is nothing but 4 value. Okay, if only this is set, right, then this is nothing but 16. Okay, if only this is set, right, then this is nothing but 64, right? Here this is how you write the binary form, right? 1 2 4 8 16 32 64. Okay, so we need only this, right? Here let's suppose if I'm taking my n is equal to 16, n is equal to 16. So how I'm going to write n equal to 16? I am going to write 16 like this: 1 1 0 0 0. Okay, in binary form, right? 1 2 4 8 16. All right, you have to just simply do the AND of this number with n minus 1. So n minus 1 is nothing but 15. So n minus 1 is 15, so it is going to set all other bits, right? And here 0. So this is nothing but n, this is nothing but n minus 1, and you are going to do the AND of these two. Okay, so if you are going to do the AND of these two, so what is the value that you are going to get? You are going to get 0, right? So if this is equal to 0, then that simply means that our number is a power of 2, right? I can prove this for, let's say n is equal to 16. So yes, 2 power 4 is 16. So this is a power of 2. Okay, same way if I ask you, tell me if n is equal to 15 is power of 2 or not. So how you're going to write 515 in binary form? You're going to write like this: 1 1 1, and here this is nothing but your n, and what is your n minus 1? N minus 1 is 14. How you write 14 in binary form? So you are going to write 14 like this: 1 1 1 and 0. Okay, 8 4 12 13 14. Okay, this is how you write n minus 1. Okay, if you do the AND of this one, so right now here see, you are going to get this, which is not equal to 0, right? So that simply means that 15 is not a power of 2, right? Okay, so this is how we calculate. Okay, so this is the one thing that we need to calculate, right, for a number. Okay, and then also I need to make sure that this that these are set. Okay, bit at even positions, right? Bit at even positions are set, right? So here bit at even positions, right? So here this is 0 2 4 6 8 10 12 14 16 18 20 22 24 26 28 and 30. Okay, so bit at even position should be set for the number to be divisible by 4. Okay, to be a number power for power of 4. Okay, so bits at the even number should be set. Okay, so for that what I'm going to do, I'm going to take this number 16, let's say 16. Okay, I'm going to take this number 16, right? And let's compare this 16 with 8. First of all, 8 is also divisible by 2. Okay, 8 is power of 2, 2 power 3, and 8 is 16 is also 2 power 4. Okay, so both are true here until here. Okay, right? And 5 is not a power of 5 is not power of 2, right? So here I am simply going to return false. Okay, using this condition, right? N is equal to 5 and n is equal to 4. Just do the AND. So you are going to say you're going to get not 0 here, right? So that's simply 5 not the power of 2. Okay, but here 8 and 16 both are power 2, but 8 is not divisible by 8 is not the power of 4. Okay, but 16 is power of 4. So how I'm going to prove that? So take 8 take 8 and do the AND of this one with this one. Okay, all these are the values. Okay, with all these values 0 1 0 1 0 1 0 1. Okay, because we only need even bit set, right? So 8 and with this what the pattern I've shown you, right? 0 1 0. Okay, this pattern. So 8, how you're going to write it in a binary form? you're going to write like this, okay, 1 0 0, right? And other thing, this how you're going to write 0 1 0 1, right? This pattern, if okay, if you notice 0 1 0 1, okay. So here if I just do the AND of these two, let's say, so I'm going to get here 0, here 0, here 0 0, okay, everything is 0. So if here I'm getting 0, right? Same way I just check for 16. For 16, how I'm going to write 16, I write 16 like this, 1 0 0 0, okay. And here I can write it like this, 1 0 1 0 1 0, okay. 1 0 1 1 0 1, okay. So now here I'm going to get, if you notice, I'm going to get 1, okay. I'm not getting something equal to 0, but I'm getting something equal to not equal to 0 right here. So if I'm getting something equal to 0, then simply return false, okay. So it should not be equal to 0, right, okay. So this is what I need to make sure, okay. So bit at the even position should be set, right, okay. So here bit at the even position is not set, right? Here if you notice 0 1 2 3, this is odd position, right? Okay, but here if you notice 0 1 2 3 4 bit at this position is set, okay. So this is what you need to do, okay. So here you can write this number in a decimal form, okay. This binary form I have written here 0 1 0 1 0, okay. In a decimal form you can write, or you can write it like this, okay. So what is this value? This value is nothing but 5, right? This value is 5, okay. Same way if you pick this value is also 5, 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 okay. This value, if you just pick this part, okay, I can say this is 5, okay. This is also 5, this is also 5, right? Here if you start from here, 0 1 2 4 0 1 2 4 0 1 2 4, okay, 5. So total how many 5s are there? 1 2 3 4 5 6 7 8, 8 5s, okay. So I can say 5 8s. So this is nothing but a hexadecimal form, okay. This is nothing but hexadecimal form. So to represent this hexadecimal form, okay, in programming languages, what we need, what we do, we take this, okay, like this, and in front of this we use 0 and here x value like this. So this is how we write, okay. So this is nothing but the hexadecimal form, okay, of this particular binary form. So I need to do the end of this one with my n value, okay. So now let's write the code for this one. So it's very simple, return n is greater than 0, and here we have to make sure that uh, n is divisible by 2 first, okay, and n minus 1, all right, okay. Here it should be equal to 0, okay. So here let me do one thing, let me write it here, okay. I want to show you one more thing, and here let's say and here I have to do n and with, here I have explained 0 x, okay, how we write it in binary in this hexadecimal form in programming languages, 555, okay, 4 5 6 7 8, okay. And this value, it should not be equal to 0, okay. So that's it. Now if I run it, so see, all the test cases has been accepted. Now let's submit it. So see, our solution is accepted, right? Now if I don't write this condition, what will happen? Okay, so then in that case, okay, if I don't write, so in that case for 5 also it is going to return true, right? 0 1 0 0 1 2 4, okay. Now if you do and with this one, so this one is also like this, now 1 0 1 0, okay. So it is going to give you 0 0, okay. Then you are going to simply return true, right? So now if I run it, so now you notice this, that for 5 this value is coming out as true, but expected is false, right? So that's why we have to write this condition, okay. Number should be power of 2, and then once we verify that it's the power of 2, then after that I have to make sure that the bits at even position set, okay. So that's it. So I hope that you guys are able to understand today's problem, and if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you in the next video. Thank you. Bye bye.